Okay, today I'm going to do the last unit, which is modules 11 and 12. So I'm going to look at the notes, and as always, I'm going to go through the notes, and then at the end, I'll go through the homework. So we're going to be talking about matrix and matrices, and don't let these notes intimidate you. I know it's a lot to look at, but I'm going to try to go through everything just a little bit to help you understand. So, a matrix is going to look something like this. You're going to need your brackets, and then there are numbers that are inside of your matrix. There are rows and then columns. So your rows are what's going horizontal, and then the columns are going up and down. And then some definitions, you have a square matrix, which is a matrix that is square, so the same number of rows as there are columns. And then there's a row matrix, a matrix with just one row. A column matrix is a matrix with just one column. And then the dimensions of the matrix. Two matrices are equal if they have the same dimension and if the corresponding elements and the positions are equal. So 2 and 2 are the same, 1 and 1 are the same, but we have -5 and then +3. So these are not equal. And then adding and subtracting matrices. So only matrices of the same dimension can be added or subtracted. So an example, we have one matrix right here and then another right here, and we are adding them. So basically the number that is in the same position, those are the ones that are going to be added together. So in this position, we've got -3 and -1. That is what we're going to be adding together. And then we'll do different colors. 4 and 9, we're going to add those together. -2, -1. And then last is going to be the 5 and 3. And you end up with this matrix. Same thing with subtraction. You're going to subtract the numbers that are in the same position. In scalar multiplication, a scalar is like a number that is in front of your matrix, and you're going to multiply every single element by that number that is being multiplied in. So in this case, it's number 4. We multiply 4 to every single number in our matrix, and we end up with this as our answer. This says to find the values that makes these matrices equal. So we've got the color codes already here, and it tells you what each letter would equal. Multiplying two matrices. So matrix A, the dimensions are 3 by 2. That means it has 3 rows and 2 columns. And then the second one, matrix B, has 2 rows and 4 columns. So the number of columns in our first matrix must match the number of rows in our second matrix. So the columns in matrix A must be the same as the number of rows. And then there are some examples down here of multiplying. So once you determine that these two are equal, then you can multiply. So when you're multiplying two matrices, remember that it is row times column. So I'm going to rewrite this because this can be confusing. All right, Don't let these lines confuse you. I know it kind of looks confusing, but let me just write it right here. So that is, if everything is kind of color coded with its position in the matrix, I will go over more in the homework. For 12.1, it says to utilize the Gauss-Jordan method to solve the system of equations. So we're going to be looking at linear equations that are in this form: ax plus by equals c, in the standard form. Linear equations are of first degree and graph a straight line. So we're not going to be dealing with x squared, y squared, or any parabolas or anything like that. It's just going to be some straight lines. So basically, a system of linear equations can be solved by elimination or substitution. So we can combine two different equations to solve for x and solve for y and find our solution set. So we can do this an easier way by using a matrix or matrices. So here's an example. It gives us the same problem that we just had up there, and then it shows you how you can put it into a matrix and solve for x and y that way. And then this talks about like inconsistent systems, systems that are dependent. So if x equals y or y equals x or something like that. 3 variables. And then 12.2, inverses. So here's an example. They give us this matrix. We have -1, 4, -2, -1. And what you're going to do is set up a larger, you're going to add on that identity matrix, which is just 1, 0, 0, 1. Once you add this on, the matrix is no longer a square matrix. It becomes one that is 2 rows and 4 columns. And you're going to work this similarly to how you do it in 12.1, where you get 1, 0, and then 0, 1 in these first part of the matrix, and it'll tell you what the inverse is. And so basically, like when you multiply your first matrix that we were working with by its inverse, then you get your identity matrix. So look at some of these examples down here in the notes, and I'm going to go over the rest of the... Alright, so the homework for 11.1, remember I'm only going to go over the questions to look out for on the test. I'm going to start with number 1. It says to find the values of the variables for which the statement is true, if possible. So it gives us 2 matrices, and it says that these are equal. So if they are equal, they have to be the same dimension, which they are, both a 2 by 2. And then also each of the pieces in the same position must match. So our first column, first row has to be the same in both of these matrices. Same thing for the second column, first row has to match the second column, first row, and over here. And all the way across they have to match. So I've got -3 and then x and then y. We want to find out what each of our variables equals. So we can see that -3 is matching up with w. So w equals -3. X is the same position as -4, so x equals -4. Y and -7, y equals -7. And then z equals 2. Yes, they look alike. Put a line through it. Z equals 2. So we're just going to come over here. W equals -3. X equals -4. Y equals -7. And Z equals 2. Alright. Alright, I'm also going to go over number 2. Oh, this is number 1. This is number 2. And it says to perform the indicated operation if possible. So we have 2 matrices and we are going to add them together. Remember, whenever we add them, they have to be the same dimension. So I've got 0, 4, 1, 9, and then -4, 7, 7, -8. And we are going to add these. Now, whenever we add these, the numbers that are in the same position is what we are going to add together. So we have 0 and then -4, 0 and -4, and that when we add those together, that equals -4. We've got 4 and 7. 4 plus 7 equals 11. We've got 1 and 7. 1 plus 7 equals 8. And then the last one, we've got 9 and then -8. 9 plus -8. Same thing as 9 minus 8 equals 1. So this would be our final answer. Whenever you are entering your answer into Pearson, just click in the box and you're going to use this matrix button at the bottom. Click on that and this will pop up. Our matrix is a 2 by 2, so we're going to click OK, and it has created it for us. And all we have to do is put in our numbers of our final answer. And that's it. I am also going to do number 3. So we've got 9, 0, 5, and we are subtracting that. We're subtracting -7, -1, 4. Okay, so the same principle is going to apply to this. We're going to subtract the numbers that are in the same position. So I've got 9 minus -7. So we have a double negative, and that's going to become positive. Let me go ahead and write this out. So 9 plus 7 gives us So 9 plus 7 gives us 16. The second row, we've got 0 minus -1. So same thing, we've got a double negative. It becomes positive. 0 plus 1 is 1. And then our bottom row, 5 minus 4 is also 1. So I'm going to click on our matrix, on our box, and click on the matrix button. So we have 3 rows and we only have 1 column. Click OK, and I've got 16, 1, 1. All right. We are going to also do number 4. So I know that this one can look a little intimidating, but we're just going to follow the same principle that we've been doing. So the values that are in the same position is what we are going to subtract. So for our first row, first column, we have the square root of 3 minus the square root of 3. That is just going to give us 0 here. The first row, second column, we have negative 2 minus 9, which is going to give us negative 11. The second row, first column, we have 2 minus negative 2, which is going to be double negative, so it's going to be 2 plus 2, which we get 4. The second row, second column, we have the negative square root of 5 minus the square root of 5. So this one is similar to this first row, second column, when we had negative 2 minus 9. This case, we have negative square root of 5 minus the square root of 5. So we have 2 square roots of 5 now that are being joined together. And since we have our negative and then a minus, it's going to stay negative. So we have negative 2 square roots of 5. For our third row, first column, we have negative 8 minus negative 7. So we have a double negative. Negative 8 plus 7, we get negative 1. And then the third row, second column, we have a square root of 8 minus 3 square roots of 2. So I'm going to write this out over here. Square root of 8 minus 3 square roots of 2. So 8 can be rewritten as 2 cubed. And we would keep that under the square root. So 2 cubed is going to be 2 times 2 times 2. So we can kind of break this up. We know that 2 times 2 is 4. And remember, all this is under our square root. So 2 times 4 is going to give us that 8. But we also know that the square root, because we can rewrite this as this. The square root of 4 equals 2, because 2 times 2 equals 4. So since this equals 2, I can rewrite the square root of 8 as 2 square roots of 2. And we're going to do that minus 3 square roots of 2. So 2 minus 3 is going to give us negative 1. So I'm just going to do negative square root of 2. So that is going to be our last piece. Okay, so I have actually wrote this out wrong. I am missing this 2 in front of this. So that means that this one is incorrect. So we have the square root of 3 minus 2 square roots of 3. So we basically have 1 square root of 3 minus 2 square roots of 3. So 1 minus 2 is going to give us a negative 1 square root of 3. So the only one that we had incorrect was this first piece. Awesome. Okay, I'm also going to do number 5. Let me scroll down here. It says find the sum if possible. So same thing that we've been doing, we're just going to take the values that are in the same position and we're going to add them. So 4x plus y plus 5x (5x) plus 5y plus 3x, and then we have negative 3y plus 5y, and then 2y plus x equals, we're going to join our x's, so we have 9x plus y And then we have 8x plus 5y. And then we have 2y. And then the bottom one, we cannot join our values together, so 2y plus x, or we'll put x plus 2y. The order shouldn't matter. So let's see, 9x plus y, 2y, 8x plus 5y, and then let's see if order matters. We'll do 2y plus x. Great. So order should not matter on these. All right, and then also there's going to be one like this. So number 6. It says A equals the matrix 6, -1, 0, 8. And we want to find -2 times A. So -2 is going to be our scalar. So all we're going to be doing is multiplying -2 times every single value in our matrix. So -2 times 6 gives us a -12. -2 times -1 is a +2. 0 stays the same, and then -2 times 8 is a -16. All right. And then I don't believe, well, actually, okay, we're going to do number 7 as well. B equals -10, 2, 6, 0, and we want to find 5/2 times B. So that means we are going to multiply 5/2 times every value in our matrix. 5/2 times -10, we can cancel the 2 out. 10 divided by 2 is 5, but this is a negative. So 5 times a -5 gives us -25. 5/2 times 2. The 2's cancel out and we are left with 5. 5/2 times 6. The 2 will cancel with the 6 and we're left with 5 times 3, which is 15. And then we have 0 at the end. All right, number 8. We are going to multiply. So remember the rules when we are multiplying the matrices. We have to look at their dimensions. So this is going to be a 2 by 2, and this is a 2 by 1. So these two pieces have to match, and they do, so that means we can find our product. Now, when we find our product, we are going to take these two, and our dimensions of our answer are going to be 2 by 1. So that means it's going to be like our second matrix. And when we multiply, you're going to do it by the row times the column. So for our first piece, our row 1 and the column 1, we're going to take 2 times 4, which is 8, and then add it to 0 times -9, which is just 0. So we are left with 8 as our top value. For our second value, again, it's going to be row times column. So 4 times 4 is going to be 16. And then plus we've got -7 and -9, which is going to be 63. And then 16 plus 63 is 79. So we've got 2 rows, but 1 column. And we've got 8 and then 79. Oh, Number 9, we're going to do this one as well. So we've got, but remember we need to look at our dimensions. This is 2 rows by 3 columns, 2 by 3. And then this one is 3 rows by 1 column. So these two match, yes. So we can multiply them. And then we've got 2 and then 1. So our product, our answer, the matrix is going to be 2 by 1. Okay. So I'm going to do blue for our top position right here. So we take 3, let me actually make this a little bit bigger. All right, so we've got 3, remember our top row, times the column. So 3 times -1 is -3. And then we've got -3 times 4 is -12. So minus 12. And then our bottom is 1 times 2. So plus 2. Okay, and then over here, second row, same column, we've got 3 times -1, -3, 0 times 4 is 0, and then 3 times 2 is 6. So our final answer is going to be, we've got -3 minus 12 plus 2. So we've got -13 and then 3. All right. And then the last one for this homework is going to be number 11. And we've got, so same thing, we've got 1 row and 3 columns, and then here we have 3 rows and 3 columns. So our product is going to be, these match. Yes, our product is going to be 1 by 3, so like our first matrix. So I'm going to do it like this, and I'm just going to say 1 by 3. We have to multiply this row to every single column, and that's how we're going to find each of our values. So the first one, our row by our first column is going to be this piece right here. So I've got -1, this is going to be -1 times 2, which is going to be -2, and then 4 times 2 is 8, so plus 8, and then 1 times 0 is 0, so I'm not going to put anything there. For our second piece, our middle value, same row, the second column, -1 times -2 is a positive 2. 4 times 2 is 8. And then 1 times -1 is -1. And then the last value, we're going to use this third column over here, same row. We've got -1 times 4 is -4. 4 times 0 is just going to be 0, and then 1 times 2 is 2. So our answer, -2 and +8 is going to be +6. 2 plus 8 is 10 minus 1 is 9. And then -4 plus 2 is -2. Awesome. And that's going to be the last one for this section. For 12.1 homework, this one is looking at the system of equations. So let's do like this dark blue. This is 12.1. We are not going to do number 1, but we are going to do number 2. So it says to use the Gauss-Jordan method to solve the system of equations. So they have given us negative 15x minus 3y plus 66 equals 0, and then 6x plus y minus 27 equals 0. So we're going to put these equations, set them up into a matrix, and we can solve for x and y. So we're only going to use the values, so negative 15, negative 3, and then 66. We're not going to put the zeros in there. And then we have 6, 1, and negative 27. So what we want our matrix to end up like, we want 1, 0, and then a number, and then 0, 1, and then another value at the end, because that's going to tell us that x equals this value over here, and then y equals this value. We're going to be doing some manipulating in our matrix to get it to the 1, 0, and a value, and then 0, 1. So we already have a 1 right here. We're going to start with the first row, and we want to get a 0 where the negative 3 is. So let's manipulate our second row. Let's multiply this by 3. And so we get negative 15, negative 3, 66, and then we've got 6 times 3 is 18. 1 times 3 is 3. And then negative 27 times 3 is negative 81. So now that we have manipulated this, we are going to add row 1 and row 2. So when we add, we get 18 and negative 15. I get positive 3, 0, and then negative 15. And remember, we need a 1 here, so I'm going to divide everything by 3. So I end up with 1, 0, negative 5. So this is dealing with our x, and what this equation looks like now is that x minus 5 equals 0. So that means that x equals positive 5. So we found our x. That's going to be our first row. Now we need to find our second row. So when we are manipulating for the second row, I'm going to use our new row 1, and we'll use the original row 2. So 6, 1, negative 27. And so we have a 1 here. We just need to get a 0 to where the 6 is. So I'm going to manipulate our first row. Now, I know this is kind of weird because we've already found our x, and it can be weird to be changing that first row, but it's okay. We already found what our x is, so we can manipulate this. This is going to be multiplied times a negative 6 for this first row. We're just going to be manipulating this so we can figure out what the second row is. So multiply everything by negative 6, and I get negative 6, 0, and then negative 30, and then I got 6, 1, negative 27. I'm going to add them together, and I get 0, 1, I'm sorry, this is positive. 30 minus 27 is positive 3. So we get that y plus 3 equals 0. So y equals negative 3. All right, so it's going to be the one solution. You're going to put it in parentheses, and we get 5, negative 3. Awesome. I am also going to do number 3. So same thing, we're going to use the Gauss-Jordan method to solve the system of equations. All right, so let's put it into our matrix. I'm going to use a pink. I've got 3, -7, 2, 6, -14, 1. So remember our final answer, we want 1, 0, 0, 1, and then we'll have some values at the end. So let's start with our first row. I'm going to multiply by -2 to our top row. So we've got -6, +14, and then 2, and then 6, -14, and 1. And now I'm going to add row 1 and row 2, and I get 0, 0, and then 3. So what this means is the system is inconsistent because we did not find a value for x and y. So that would be your answer for that one. All right, let me do this one, number 4. All right, so let's put it into our matrix. I've got 3/8, -1/2, and then 5/8, and then I've got -6, 8, and -10. So something we can do is multiply our top row by 8 because that's going to give us something that's easier to work with than fractions. So if I multiply our top row by 8, then I get 8 is going to cancel out with the 8 over here, so I get 3. 2 cancels out with the 8, and so you get -1 times 4, so -4. And then the 8s cancel out over here, so we're left with 5. And then you've got -6, 8, and -10. So if we want to get a 0 where our -4 is, multiply the top row by 2, which gives us 6, -8, 5, and then -6, +8, and -10. This 5 times 2 is going to be 10. So when we add row 1 to row 2, we get 0, 0, 0. What that means is there are infinitely many solutions. So they have y in here, so we need to figure out what x is. So infinitely many solutions. I'm just going to take our second equation because it's easier to work with. -6x plus 8y equals -10, and we're going to solve for x. So -6x equals -8y minus 10, and then divide by -6. So I get that x equals 8y over 6 minus, actually it's going to be positive 10 over 6 because our negatives are going to cancel out. So our x equals, I'm going to reduce it down because 8 over 6 can be reduced to 4/3. And then 10 over 6 can be reduced down to 5/3. So our value for x would be 4/3 y plus 5/3. All right. And then number 6 is going to be the last one for this section. All right, so this one is going to be pretty long. If you want to fast forward, you can do that. They only gave us 2 equations. So we're going to find the values of x and y, but not z. So our final product is going to be 1, 0, and then we'll have some values down here, and then 0, 1, and then some values right there. So that's what we are looking for. Let me do this blue. So it actually might be easier to get a 0 where our 3 is first, because if we were to multiply this by -3, then we could cancel these out. So let's do that. So we get -3, and then -5 times -3 is +15. 3 times -3 is -9, and then 1 times -3 is -3. And then we'll have our second row. And we are going to add row 1 and row 2. And we get 0. 15 minus 4 is 11, -9, and then 3 is -6, and then -3, -1 is -4. Okay. So we have 1, -5, 3, 1, and then 0, 11, -6, -4. This is our new row 2. So something we can do is divide our second row by 11. That will give us the 1 right here. So I've got 1, -5, 3, 1, and then we've got 0. 11 divided by 11 is 1, and then I've got -6 over 11, -4 over 11. Okay, I can now multiply this by 5 to cancel out our -5 on top. So 1, -5, 3, 1. Multiplying by 5. 30 over 11, and then -20 over 11. And then I can add row 1 and row 2, and we get 1, 0. All right, so what this means is x plus 63 over 11, z equals -9 over 11. And then y minus 6 over 11z equals negative 4 over 11. When I originally added these back here, I did not bring the negative over. I had added them. So when I added them, I had gotten 63, but the correct answer would be 3 over 11. So I went back and changed that to be 3 over 11. And so we get that x equals, you've got negative 9 over 11 minus 3 over 11z, and then y equals negative 4 over 11 minus plus 6 over 11z. So just be careful with your negatives. This is the last one I'm going to look at for 12.1. For 12.2, I'm going to start with, it says to find the inverse if it exists for the matrix. So remember for the inverse, you are going to use the identity matrix added on, and you'll work it similarly to how we've been working it to figure out what your x and your y is. That will give you your inverse matrix. So this is 12.2 and number 1, and we're going to find the inverse of, you got negative 1, 2, negative 5, negative 1. What we're going to do is basically add on your identity matrix. So I'm just going to do like a dotted line right here and add it on, but it's just 1, 0, 0, 1. And what we're going to do is work this out to be 1, 0, 0, 1, but then we're going to have some values at the end. And this is going to be our inverse matrix. So let's get started. So 1, negative 2, 1, 0. And then we've got the negative 5, negative 1, 0, 1. All right, now I'm going to multiply 5 to row 1, and then I'm going to add it to row 2. So previously I did this in 2 steps, but I'm going to join the steps right here. So 5 times row 1 would be a 5 here. 5 and negative 5 would give us a 0. Negative 2 times 5 is 10, negative 10. Minus 1 is negative 11. 1 times 5 is 5, and then 0, 5, and then 0, and then plus 1 would be 1. And then we've got 1, negative 2, 1, 0 for our first row. So the row 1 stayed the same. We just manipulated our second row. Like I said, usually we've done this in 2 steps, but now we're doing it in 1. So I'm going to now divide row 2 by 11, negative 11. And so I get 1, negative 2, 1, 0, and then 0, 1, 5, negative 5 over 11, and then negative 1 over 11. So we have our 1 here. Now I just need to get rid of our -2. So I'm going to do, for our new row 1, we're going to do row 2 times 2 and then add it to row 1. So our bottom row is staying the same. Our top row is not. So 2 times R2, so 2 times 0 is 0, plus 1 is going to give us that 1. These two are canceling out, so 2 times 1 and then -2 is 0. All right, 2 times -5 over 11, it's going to be -10 over 11 plus 1. So let me put that over here. So this would be the finished product. I did write everything out and the work is off to the side. If you want to go back and look at this, I'm not sure where the recording went, but all of the work that you need is right here. 21 also. So same thing that we just did. Number 2, find the inverse. So we've got 5, 10, 5, 10. So we're going to do it the same exact way that we just did. We are going to add the identity matrix on at the end. And remember, our final result is going to be 1, 0, and then some values, and then 0, 1, and some values. So this is what we're looking for. So first thing I'm going to do, so I'm actually going to divide everything by 5. And we end up with 1, 2, 1/5, 0, and then 1, 2, 0, and 1/5. Now it's a little bit easier to work with. I have my 1 here. Let's get a 0 where our top 2 is. So I'm going to multiply the bottom by -1, and then I can add that row 2 to row 1, and that'll be our new row 1. So this one is not going to work out because every time I try to do a manipulation in order to get like a 0 or something, it zeroes out the matrix, so the inverse does not exist. That was number 2. And then the last one that I'm going to do is this one. Solve the system by using the inverse of the coefficient matrix. So number 4. All right, number 4 is going to be the last one that I'm looking at. So it says to solve the system by using the inverse of the coefficient matrix. So how you're going to do this one, you're still going to set this up how you would normally by taking the numbers and not putting your x's in. So this is how you would set this one up. So the first part, it says to find the inverse. So our coefficient matrix is going to be A, and I'm going to give you a little trick when you are finding the inverse. What you're going to do is look at your first matrix, and these two values are going to stay the same. So the 2 and the 1 are staying the same, and then the negative ones are going to be switched. They're the same thing, so it doesn't really matter. But what we also need to do is negate them. So if you're switching them and it's positive, you're going to make it negative, and if it's negative, you're going to make it positive. So what we end up with is this. So this is going to be the answer for the first part. Our inverse of the coefficient matrix is going to be this. The next part it asks about is the solution set of the system. So to find this, you are going to take your inverse matrix, so 1, 1, 2, 1, and you'll multiply it by your last matrix on the end. So we have a 2 by 2 and then a 2 by 1. So our final product is going to be a 2 by 1. So 1 times 0 is 0, plus 1 times 3 is 3. So we have 3 right here. And then we've got 2 times 0 is 0, plus 1 times 3 is 3. So when we give our answer, they want it as a solution set. So it says type in ordered pair, so we're going to do it like this. All right. So that is all the questions for the test.